Hi there. You are looking at a web visualization using webGL using a library called REGL that I want to talk about today. And what it is it's an environment that allows you to work with webGL in a way that is declarative. So it's functional programming. Um, in a way, it is a very small library. It's pretty easy to get up and running with shader language. Um, and it lets you do amazing, amazing things like that one we were looking at, or this audio graph. Um, Bellwoods is another one. It's really nice animation, super crisp, super fast and responsive. Now there's a lot of and it will allow you to create a lot. You can draw, see, 100,000 points particle animations, which is far more than you can do in, say, the canvas. Um, and so I'm viewing this series. I'm viewing this library. I'm thinking about this library as being um, useful for my creative coding students who have some background in P5, or anyone really who has background in P5 or other Canvas libraries, um, or just with the Canvas. I think maybe this video would be useful for people who have some background in 3.js or with WebGL. Regal lets you do the WebGL things, but sort of more easily. It takes away a lot of the tedious and off-putting stuff about WebGL. Um, but I also think this could be great, a great library for web developers. Some students of mine who have a background in React because of its declarative nature. It looks and feels kind of like React for WebGL. So let's dive in and get started with a with Regal. And what I've done is made a repo, a couple of repos actually, and I've put these in the description for this video. But the easiest way I think to get started is to download this repository, basic Regal, and I'll just show you around a little bit. So you can grab this link here, and what I'm going to do is open up my terminal, and I'm going to cd to my desktop, and I'm going to say git clone that repository. And if you don't have Git installed, you can obviously just download this repository here, download the zip, and open it up. And then drag that onto VS Code and take a look at it. Now, an important note, if you're going to be pushing changes to GitHub later on, you may want to fork this repository so that you end up with your own GitHub repo that you can push changes to. Or you could just start your own Regal project from scratch and set your remote origin in there. But for now, we're just going to look at this basic Regal folder, and notice that there's a test sketch folder that's got 3 files. It's got an index.js, which is some JavaScript. It's got a vert.glsl, which is a vertex shader. And it's got a frag.glsl, which is a fragment shader. And so When working with webGL, um, these, and when working with REGL, these are going to be our three main file types. We're going to have an index.js that instantiates REGL and draws our output, and it's going to bring together a fragment shader and a vertex shader to create and run those. With the vertex shader and the fragment shader, it'll utilize the GPU to get extra fast processing for our sketches. And at some point, I'll show you how to export these sketches and all those kinds of great things in other videos. But for today, we're just going to look at getting started with REGL. And so you can see I've got this test sketch folder. I've also got a package.json. And this package.json is going to define the dependencies for my application. It's going to be a Node application. So we're going to be using Node, and if you don't have Node installed, I made a separate video on installing Node. But for now, I'm just going to assume that I'll put the link to that in the description for this video. For now, I'll just assume that you have Node installed. I've maybe used it before a little bit, or a lot, and know what it does. So we've got these dev dependencies: browserify, Budo, glslify, and this canvas sketch we won't use today. And then our main dependency right now is this library REGL. So we'll get started using that. And to get started, we just need to say npm install. That's going to grab our dependencies and put them in our node modules folder, where we can then use them in our sketch. And the test sketch is in here. And here we've got a start command that I've written as a script that'll run this Budo application, which will live serve --live serve our project. It's going to open the project that's located in this folder test sketch at index.js. And so we can look at index.js and get a sense of what's going on here. And all that's happening is we're bringing in REGL and glslify, and we're creating this new instance of REGL that we're drawing in a frame. And we'll go over all that more in detail, and we'll actually build this from scratch so I can show you some stuff. But I'm just going to go npm start, and let's make sure everything's working. And that's not much of a color, but I think it's working. Let's take a look. Did I goof? It should be a color. So we'll have to take a look and see what's going on here. bgcall, math.random, save that. There we go, it's a color. I'm not sure why that was. So maybe that's something to notice, is if you've got nothing, try just making sure and double check and save these files. Not sure why I would do that, but so it did. And again, there we go. So there's a randomly generated color. Not very exciting, but this is REGL in action. And let's just delete everything in this file and start from scratch. So now we've got nothing in this file, nothing's appearing. What we need to do to start to make a REGL project is to first require REGL, right? And so when we require REGL, and you know, if you really want to know how to do this whole build process and everything else, I'm going to go over that in another video and probably the next video. But for today, for this video, what I want to do is just focus on what it is that REGL is doing and how can we, what does the syntax look like? So we'll require REGL, and we'll require GLSL of phi. And what we're doing is just importing that code into this sketch, which then Budo is going to build for us and output to this web browser. And the way that REGL works is in some ways a lot like P5, happily, in that what we need to do is we need to call regl.frame and pass in a setup function. So regl.frame you can think of as your P5 draw function, and this regl.frame will loop and loop and loop, and I'm going to call this draw BG, and this is going to be a function. Now, when I was saying that the REGL is declarative in nature, that means that it's a lot of composing using functions. And so here's a very interesting thing to me. You know, when we bring in REGL, when we require REGL, we're actually going to pull, where you get from REGL, we get a function, which we then have to call. And we can call that with some setup parameters, which we can pass in via an object. We're not going to do that just yet, but soon in other videos we'll be doing that. And now you can see here I'm getting an unexpected token on line 7, which is basically telling me you don't have this draw background function. So I'm going to write this function. And there we go. So now I'm drawing BG. Require Celify. What are we doing here? Unexpected token 712. Parsing file. Doesn't like that. Regl.frame. Oh, whoops, my bad. That's my mistake. Because, again, what we need to do is pass in a function into regl.frame. And in that function, we'll execute this call to draw BG. So REGL is, you know, just like with React, we're doing a lot of composing with functions. And that style may be a little bit new to those of you who are coming from a P5 background. And if you're not familiar with arrow functions, at some point I'll make a video on arrow functions, but I'm going to leave it up to you to search that out. Just know this is a syntax which is basically the same as saying function. And we could actually replace this with function, and it'll work just the same. At least it should. Oh no, you know what we'll do is we'll say like this. That's, yeah, I need to have the other. And so we can replace that with a function, and we can honestly also do this. We can say REGL frame and pass in draw function, and then say function draw function draw BG. And that would have the same net effect. But I really like these arrow functions, and if you're not familiar with them, go learn about them. They're amazing. Super, super great part of our toolkit. Obviously, if you've been coding in React or been coding with me in my courses, then you probably are well familiar with arrow functions, because I love them. And so there's our regl.frame. This frame is going to loop and loop and loop, and it's going to draw background every time. Right now, it's not drawing anything because we're not passing anything into this regl function. And so let's put that code in there now. And maybe we'll start by just drawing a full screen color like we had before. And so what we'll do is make a random color, first of all, const bgcall equals an array, and we can talk about color values in webGL, which are always going to be numbers between 0 and 1. So they're going to be floats, and there should be 4 of them. And that's going to be RGB as floats in an array. And now we can pass this value in to our REGL function. So draw background, right, is a constant that we're assigning to REGL here and passing in an object. That REGL function that we're importing up here is going to in turn return a function which we can call here. Make sense? If it doesn't make sense now, don't worry, it will. One of the great things about, I think, using REGL, using React, is it teaches us about this functional declarative approach, which I love. And so in subsequent videos, we'll talk more about this in the details, and maybe I'll even make a little series of videos on functional programming in JavaScript. But for now, let's just keep working on this draw BG object. And so if we go back to the REGL help files, right, we can see that REGL simplifies WebGL programming by removing as much shared state as it can get away with. We know that shared state is where side effects happen, right? To do this, it replaces the webGL API with 2 fundamental abstractions, resources and commands. And so calling REGL, we can see here, creates a new partially evaluated draw command. And then down here, we can see we draw the triangle inside of a REGL.frame. And I put a link to these docs in the description. If you want to learn more, we'll be going over a lot of this stuff in subsequent videos. And there's, lots of different ways to write REGL code, but you can see here, we just require REGL, and we can require it in various ways, passing in some setup stuff if we want to, but we don't want to today. Today we're going to just talk about commands, these draw commands, and run them, a few of them. And I think today, for this video, I'm just going to look at, first of all, drawing the whole screen and then drawing a triangle, which is sort of the hello world of REGL. And so here we are. We've got our BG call, right? And I'm going to use that in this draw command, which I'm already running. So first, I'm going to specify a fragment shader. And this is why we're using REGL, right? Is because we want to learn about shaders. And we want to be able to use shaders, because shaders are so amazing. And I'm going to use GLSLify, which I brought in. And GLSLify is used as a kind of a portal between JavaScript and fragment shaders. It lets us use fragment shaders in our JavaScript. An alternative to this is to just use backticks and specify our fragment shader there in the backticks. But I don't like that because it's so hard to tell what's going on. You'll see examples on the web where people do that. They just specify a frag and a vert and put the code in there. But I much prefer to have, and we can see, just show you just to compare. There's the vert file that I already wrote. If I bring it in here, It's just harder to read for me. So I'm not going to work that way. I can't work under those conditions. I'm going to use glslify, and I'm going to bring in vert.dlsl, and I'm going to do the same with my fragment shader. And I'll talk about what's going on in those in a minute, but first I want to just continue through and specify the other things we need to pass in to this draw command. So we've got a frag shader, we've got a vert shader, and the next thing I want to do is pass some attributes into those shaders. Now, this attribute is a value that's going to get sent to this shader, right? And the attributes get passed in only to the vertex shader. In our case, we're going to pass in basically an array, a vector, a 2-position vector, vec2 type, which is going to specify the x and y coordinates of our vertexes. And so in my index.js, I'm just going to say attributes, and REGL will pass whatever I specify here in this attributes object, it'll pass in as an attribute to my vertex shader. And so what our variable was called position. So I'm going to pass in a variable called position, and that variable is going to have a number of positions. And so this vertex shader will be called once for each one of these positions. And I'm going to pass in -1, -1, which will be the bottom left corner. I'm going to pass in 1, -1, which will be the bottom right corner. Is that right? Yeah. And I'm going to pass in 1, 1, which will be the top right corner. And I'm going to pass in -1, 1, which will be the top left corner. So position coordinates are by default, they're on a sort of a 1-by-1 Cartesian grid from -1 to 1 in the x and y axes, and that's what we're passing in. And the other thing I want to pass in is something called a uniform. So attributes go to our vertex shader. Uniforms go to our fragment shader. Vertex shaders are used to draw the vertexes of our geometries. Fragment shaders are used to draw pixels. And in this case, I'm going to just send in a color to the fragment shader, and it's going to draw that color for every pixel on the screen. So we'll get a screen that has just a uniform color. And this is just sort of a basic fragment shader. Soon we'll be getting into using noise patterns and gradients and all sorts of fun things in our fragment shaders. But for this one, we're just going to pass in a uniform. It's going to be called color. And we're going to set it to bgcol, which is this color I specified up here. And now the next thing I'm going to specify is a count, so the number of vertexes. And I'm going to specify a primitive type, which is going to be triangle fan. And we can draw, basically in webGL, we can draw triangles, dots, or lines, and that's it. Everything else we have to compose using those shapes. So let's just see what happens now. If I run this, save it, And look at my thing. I've got an issue. Cannot find module frag.glsl. And that's my bad. This is node, and I need to go like this. Dot. I need to specify what directory I'm looking in. And now I've got my color. There's my color on my screen. So that's kind of cool. And I can change that color, right? I can say const bgcall equals math.random, 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 no, this last one we're going to say 1. That's going to be the alpha value. And let's just save that and see if we get a random color. There we go, random color. I'm just saving this document, and Budo's handling the live reloading, and you can see my color in the background is changing every time. Yay. Now, we can also, if we want to, specify a function. Let's do that. This is going to get chaotic, I think. I didn't do this ahead of time. We'll specify a function for our color, and the color is going to return. Now, each time it'll return. Oops, let me just keep that there. Each time this runs, it's going to create a new value. And now we're getting a flickering screen with random colors each time. So you can see these, one of the great cool things about REGL is these attributes and uniforms and anything we're passing in our draw command. We don't have to just pass static values, we can pass functions. And those functions let us do really anything we can dream up, right? This is the beauty of functional programming. All right, so that's just a quick and dirty first step into REGL. I think in the next video, I'm going to show you how to make a gradient. So stay tuned for that. It'll be by soon. And until next time.